Okay, in this lesson, we're going to cover contingency tables. Now, it was brought up a couple of other times in previous lessons, but in this lesson, we're going to really focus on it and go through several examples on using contingency tables. And a contingency table is just a table that provides an easy way for us to display data that's been collected that we can use to calculate probabilities. And it's especially helpful when we are trying to find probabilities that are conditional, because it breaks everything down into the appropriate subgroups. So that way, when we are looking for a conditional probability, we can find a lot easier what the probability is based on what that given assumption is and what subgroup we need to be looking at. So in this first example, it shows data that was collected about speeding violations. And we have, when you look at the columns, we have two subgroups. We have people that got a violation in the last year, and then people that did not get a violation. And then when you look at the rows coming across, those are broken up into subgroups of people that were using their cell phone versus people that were not using their cell phone. And you can see in the entire group that was surveyed, there was a total of 755. These totals here are based on the subgroup. So this 305 is the total of people that used their cell phones while driving. This 450 subgroup was people that did not use their cell phone, etc. So we have these subgroups that we can use when calculating our conditional probabilities. Okay, in the first example, it says find the probability that a driver was using a cell phone. So this isn't a conditional probability where it says given, or it has the little line that indicates that there's another assumption. So we're going to take this out of the total group. So we're just looking for the total number of people that were caught using a cell phone while driving, and then we will take that out of the total in the whole entire group. So that would be 305 out of 755. And of course, if you want to find the decimal approximation for that, you can divide it in on your calculator, but I'm just going to write it down as a fraction for right now. Okay, looking at the next example, find the probability that a driver has no violation in the last year. Well, if I look at the table, there are two columns. One column represents the people that did get a violation, and the other column did not get a violation. And all of those people that were surveyed that did not get a violation, that was 685 people out of 755. So that will be our probability. Part C. Find the probability that a driver had no violation in the last year and was a cell phone user. So if I take the probability, I'll put N, I'll use N, let me make a label of this. N was no violation. And I'll put C for cell phone user. So I want to find the probability that we have N and C. Now, because this is given to us in a table, it's very easy to identify what this value is without really having to do any calculations. But just keep in mind that when we're doing an and statement, we would want to use the multiplication rule. But because we have this organized in a table, it makes it very easy to identify, because we just want to see where these two events overlap. So we are looking to see where there's no speeding violation. That's this category. And we're looking to see where we have the people that are cell phone users. So that is this category. And where they overlap, where it satisfies both of those conditions, would be 280 out of 755. That's this group right here that satisfies both of those conditions. So I would write this as 280 over 755. Now, part D says we want to find the probability that a driver is a cell phone user or the driver had no violation. So we want to find the probability that they're a cell phone user or no violation. Now, with the or statement, we would use the addition rule. So we would find the probability that they're a cell phone user and add it to the probability that they got no violation. But then if there's any overlap, if they're not mutually exclusive, there's going to be overlap, and we have to subtract off that overlap of C and N. Now, this is a really good way that you could visualize that overlap as well when we look at our table. Let me delete what we've done so far. That way it doesn't get too cluttered. Okay, so the people that use a cell phone while driving, that's this group here. There's a total of 305 in that group. But when we look at the total of people that didn't get a speeding violation, that's the 685. So when I come down here, the probability for using a cell phone was 305 out of 755. We want to add that to the probability of not getting a speeding violation. So that was 685 out of 755. But if you look, when we counted that data, we counted this 280 twice. We counted it in the group of people that use cell phones, and then we also counted it in the group where they didn't get a speeding violation. So 280 was counted twice, and that is why, and this is a good visual representation of why we subtract that overlap. Okay, so when I take 305 over 755 and I add it to 685 over 755, and then I subtract that overlap of 280 over 755, that's going to give me a probability of 710 over 755. Okay, part E says find the probability that the driver is a cell phone user given that the driver had a violation in the last year. So now we're making an assumption, and we can narrow it down to a specific subgroup. So if I come back up here and look at my table, let me erase all my clutter again. When I look at the table, because we want to look at specifically the people that did get a violation, because that was our given assumption in the question, we're looking at just this group right here. We don't need to look at the people that didn't get a violation, because we know in the problem it was given to us that the person did get a violation. So that's narrowing down to a specific subgroup. So we want to look to see how many people got a speeding violation that was using a cell phone. Okay, so that would be this group right here, the 25 out of 70. So the probability that a driver used a cell phone, given that they did have a violation, is 25 out of 70. Now the last example was the driver had no violation given that the driver was not a cell phone user. So this is our given assumption now. So we want to look at that specific group and find the probability that the driver did not have a violation. So now we're going to look at, again, because we have that given assumption, at a specific subgroup. We are going to look at this subgroup. And because we were looking for the people that did not have a speeding violation, we're looking at this group. So our probability is going to be 405 out of 450. Okay, in this next example, we have Muddy the Mouse that lives in a cage with 3 doors. Then we have a cat named Alyssa, and it goes through and describes, which is really cute, like Tom and Jerry, the probability of the cat catching the mouse based on what door he leaves his cage. So we have this contingency table here that's given to us, and the first part asks us to add up all the totals to verify that everything adds up to 1. So Let's see, if we look across the row that says caught, we have 1/15, 1/12, and 1/6. When you add that up, either by hand or using your calculator, you should get 19/60. When we go across the row that says not caught, we have 4/15, 3/12, 1/6, and that gives us 41/60. And then when we add these two together, that gives us 60/60, and that works. That gives us 1. So now we have to check the columns that have the doors and check those probabilities and make sure that those totals add to 1. When I add door 1 column, I get 1/15 and 4/15. That gives me 5/15. When I add 1/12 and 3/12, that gives me 4/12. And when I get 1/6 and 1/6, that gives me 2/6. When I add that all up, whether we do it by hand or on the calculator, again, adding it this way, you get 60/60, which is 1. And so those totals work as well. So for part A, that's complete. Okay, now for part B, it says, what is the probability that Alyssa does not catch Muddy? So let's use the notation NC for not caught. And so we're finding the probability of NC. If we look at the table and we look at the row, not caught, that total is 41/60. So that probability out of 1, which will give us 41/60. So that works. Okay, part C says, what is the probability that Muddy chooses door 1 or door 2 given that Muddy is caught by Alyssa? So we have a conditional probability here. So we have to take it specifically out of the column where it says that the mouse was caught by Alyssa. So if I let 1 be the event that he goes through door 1, if I let 2 be the event that the mouse goes through door 2, and then I'll let A be the event that Muddy is caught by Alyssa. Okay, so we want to find the probability of 1 or 2 given the mouse was caught by Alyssa. So since this is an or statement, we want to find the probability of 1 plus the probability of 2 minus any overlap. And because if you look back up here, we're not going to actually have any overlap in this one, because if you notice, door 1 and door 2 are mutually exclusive events. There's no overlap. You can't have both of those events happen at the same time. So we don't have to worry about subtracting off the overlap. And then once we find the probability of 1 and 2, we need to take that out of 19/60, because that is the probability in which Muddy the Mouse is going to get caught. And remember, we're making that assumption that the mouse is caught by Alyssa, so we need to make sure that we use that total rather than 1. So when we find the probability of Muddy going through door 1, given that Alyssa is going to catch him, that would be 1/15. And then when we find the probability of him going through door 2, given that Alyssa is going to catch him, that's 1/12. And then, of course, that's all over 19/60. Now, if you do this by hand, you'll have to clear the complex fraction by multiplying each of those fractions by 60 and then going from there. If you use your calculator to find this value, you want to make sure that you put your parentheses in the correct places to indicate to the calculator the order of operations that you need to find this value. So you want to make sure that you have parentheses around the entire numerator and then divide by the entire denominator. So the 19/60 should be in your denominator. So this fraction bar right here represents this fraction bar over here. Now, in the numerator, you want to make sure you put parentheses around each of your fractions. Now, when you put that in on the calculator, it's going to give you a decimal value, but you can change it back to a fraction by choosing the math menu and then choosing the first option. And then when you do that, you should get your final answer. In this last example, we have one more contingency table. And the contingency table shows crimes based on the year, and then also this represents per 100,000 people. And so this is based on the year from 2008 to 2011. So part of the problem, we needed to fill out the totals. I did that ahead of time to save a little time, but feel free to check my values. Okay, for part A, it says, find the probability of the year being 2009 and there being a crime of robbery. So we want to see where both of those things happen together at the same time. So 2009 and robbery, that would be this group that has been recorded. So we would have 133.1 out of the total, which you can see down here when I added everything up ahead of time, was 4,520.7. When you put that in your calculator and you get an estimated decimal value, let's see, you would get 0.0294 when we round to 4 places. Now, we should get the same value if we use the multiplication rule, where we find the probability of it being 2009 times the probability of having a robbery based on the fact that it's year 2009. So if we did it this way, if I found the probability of it being 2009, that would be 1,139.1 out of the total, which is 4,520.7. If I multiply that by the probability of it being a robbery, given that this is in the year 2009, if I look at the year 2009 and I take the 133.1 over, that's the robbery, out of the total for 2009, that would be 1,139.1. And so this is the probability for the chances of getting robbed in the year 2009. When you multiply those together, you should still get 0.0294. Okay, so you can do it either way, but when it's in a table, it's actually, I think it's easier to just go ahead and look at where the two events overlap. Okay, let's look at the next part. Find the probability of it being 2010 and having a burglary. So again, you can do it the long way, but I'm just going to look at the table and use the shortcut where I just look to see where they overlap. Where do both of those things happen? So 2010 and burglary, that would be this 701 out of a total of 4,520.7. When you put that into the calculator, you should get approximately 0.1551 when you round it to 4 decimal places. Okay, now for the probability of it being 2010 or there being a burglary, we need to use addition rule. And so we're going to add the probability of it being 2010 plus the probability of there being a burglary, and then subtract off anything that gets counted more than once, where if there's some overlap. Now, if we look up at the table, the probability of choosing a crime that occurs in 2010 is 1087.1 out of 4,520.7. The probability of the crime being a burglary is 2853 out of 4,520.7. And then we're looking to see if there's any overlap. Well, if I look here, I counted all of these values when I summed up the crimes that happened in 2010, and then I added up all these for the burglary. So these 701 got counted twice. So that's what I need to subtract off. So I'm going to subtract off that overlap, which is 701 divided by 4,520.7. When I put all of that into the calculator and I find the decimal place rounded to 4 values, I get 0.7165. Okay, part D says find the probability that the year is 2001 if the crime is rape. So we're assuming that this is the crime that has occurred, and we want to find the probability of it happening in 2001. So we want to look at all the values, but we're looking at it specifically in the column labeled rape because we're assuming that that crime has occurred. So we're looking at taking it out of this subgroup, which is 113.3. Now the probability that it is year 2010 means that we have a chance of 27.7 out of 113.3. Okay, when we put that in the calculator and find the decimal value for that, we're going to get approximately 2365 when we round that to 4 decimal places. Okay, last example, we need to find the probability that the crime that takes place involves some kind of vehicle, given that it happened in 2008. So we're going to look at just the subgroup of 2008 and find the probability that a crime took place that involved a vehicle out of just that subgroup. So looking up here, we have all of our values here for 2008. Now, if we want to see what's the probability that the crime that takes place involves a vehicle, we're looking at 314.7 out of the 1,222.2. So when I write this down, I'm going to have 314.7 out of 1,222.2. When we put that in on the calculator to find our corresponding decimal value, and we round it to 4 places, we get 0.2575.